This question is from GATE 2016, Mechanical Engineering Paper Set 3, question number 48. In a binary system of A and B, a liquid of 20% A, that means 80% B, is coexisting with a solid of 70% A, which means 30% B, for an overall composition having 40% A. The fraction of solid is dash. Let's find out. So let's write the given things first. Now we can see that the overall composition is made by adding some fraction of liquid and some fraction of solid. And the liquid and solid both contains A and B as their constituents. So in the overall composition also we will have some part of A and some part of B. Now we can calculate the fraction of solid in the overall composition either using the constituent A or using the constituent B. So you can choose one of those because we know the composition for both A and B in liquid as well as in solid. So I'll choose to use A as the constituent. Now for A, we can write its concentration in the solid is AS. We'll use the subscript here to denote solid or liquid or overall. So this AS is given to be 70%. Another thing to mention is that we can either use percentages or use ratios. So I'll use ratio for this, that is 70 by 100, which can be written as 0.7 in decimal fraction. Now similarly, concentration of A in liquid is given to be 20%, which can also be written as 0.2. Concentration of A in overall composition is given to be 40%, which can be written as 0.4. Now we need to find out fraction of solid in the overall composition which has 40% of A. Let's denote this as M with subscript S. Now the total concentration of A in the overall composition, that is A0, can be written as the fraction of solid, that is MS, into the concentration of A in it, that is AS, plus the fraction of liquid in the overall composition into the concentration of A in it, right? This makes the complete overall composition which has the total fraction as 100%. So we can either write this as 100, which is in percentage, or we can write it as 1 because the total fraction of solid and fraction of liquid together makes the 100% of the overall composition. So we can also write MS plus ML here is 1 because that makes the total composition. Now we need to find out MS here. We also don't know ML, but we know all other things, A0, AS and AL. Now these are our two simultaneous equations because MS and ML are having the same values in both the equations. Therefore they are simultaneous equations and we can solve them as simultaneous system of equations. So to solve this, we can multiply the second equation by AL because we are aiming to eliminate this term. So multiplying the second equation by AL and then subtracting 1 and 2. Number 1 operation that we do is second equation into AL, and number 2 operation that we do is subtracting this product from the first equation. Basically we are solving 1 and 2 simultaneously. From here, when we calculate MS, we get, doing this after eliminating ML into AL from the resulting equation, we get MS into AS minus MS into AL is equal to A0 minus AL. Now we have to calculate MS from this, so just take MS common. We get AS minus AL is equal to A0 minus AL. Let's find this out now. So MS is basically A0 minus AL upon AS minus AL, which is equal to, in overall composition, concentration of A is given as 40%. We can write this as 0.4 minus, in liquid, concentration of A is 20%, which we can write as 0.2 divided by, in solid it is 0.7, and again in liquid we have 0.2. So fraction of solid in the overall composition is nothing but 0.2 upon 0.5, which is 2 by 5, that is 0.4. Let's go back and mark the correct option. 0.4 is in option A. The fraction of solid is 0.4. To learn more about binary system and to refer to the phase diagram of binary system, you can refer to the NPTEL video Module 1, Lecture 18, Solidification of Binary Alloys. This is from the course Principles of Physical Metallurgy. The course is by Professor R.N. Ghosh. He is from Department of Metallurgy and Material Science of IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.